We're now going to talk about network ACLs. So network access control lists, known as network ACLs or NACLs for short, are different to security groups in several ways. Now, we've used security groups extensively up to this point in the course, but we haven't modified the network ACLs at all, but we've been reliant on the fact that the default network ACL allows our traffic between subnets. So let's explore that in a bit more detail. A network ACL functions as a firewall at the subnet level. It's actually hosted on the VPC router, so you remember that we have a VPC router which is responsible for routing traffic between our subnets. So any traffic that leaves one subnet goes through the VPC router before it goes into another subnet. So the network ACL is hosted on the VPC router and logically is associated with the subnet. Network ACLs filter based on ingress traffic, so traffic coming into the subnet, and egress traffic going out of the subnet. So inbound and outbound essentially. A network ACL is associated with a subnet, not with an instance. So that's one of the key differences between a security group and a network ACL. Another is that your network ACL has allow or deny rules. So you can specify allow or deny rules, whereas if you remember with a security group, you only have permit rules or allow rules. So you specify the traffic that you want to allow, and that traffic is then accepted. And if you don't have a rule allowing that traffic, it just gets dropped by default, which is what we call an implicit deny. So with a network ACL instead, you have a list of rules, and the rules are processed in order from the first to the last. And you'll see when we go over to the console that they're actually numbered. I don't show it in the tables here, but they each have a number. So you might have 100 and then 101 or 200, 201 and so on. And I'll tell you a bit more about how AWS recommend you number your rules shortly. So they're processed in order, and what happens is as soon as a allow or deny is reached, that's basically the end of the processing. The traffic is either accepted or it's dropped. And we'll see how this works. So just to compare two security groups again, if you remember, if we have a security group A, it really doesn't matter. These are VPC levels, so it doesn't matter where your instances reside. If you have a permit rule in that security group that says that the instances can talk to each other, then they can communicate directly, whether they're in the same subnet or in different subnets. Now, as they do that, they're actually reliant on the fact that the network ACL is set up correctly, because otherwise the traffic which goes between subnets must exit through the network ACL that's hosted on the router and then into and be processed by another network ACL as it comes into the other subnet. So you do need a rule to allow that traffic. Of course, with security groups, if instances communicate directly with one another within the subnet, then nothing ever goes to the network ACL. So it really doesn't matter what you have configured here. These two instances will be able to talk to each other. Now, before we head over to the console, let's just have a look at the default network ACLs. So just as with security groups, your VPC will come with a default NACL, and you can then create custom NACLs. And the key difference is this. So with a default NACL, there is an allow rule for any protocol from any source. And if you have IPv6 enabled, you'll have two rules, one for IPv4, one for IPv6. And this is inbound and outbound. However, with a custom NACL, if you just create it and save it, this is what you're going to get. You just get a deny. So as soon as you associate this with a subnet, no traffic will be able to go into that subnet or out of that subnet. So that's very important to note. Now, each subnet can be associated with one network ACL only. However, you can have multiple subnets associated with a single network ACL. Now let's just, before we go over to the console, we're going to look at one more slide. So I just want to make it very clear to you the differences between security groups and network ACLs. So security groups, they operate at the instance level, and that's specifically at the network interface level, whereas a network ACL operates at the subnet level. With security groups, you have allow rules only, and with network ACLs, you have allow and deny rules. A security group is stateful, whereas a network ACL is stateless. And if we just go back over to here, what that means is that if you have traffic coming into your subnet and the network ACL allows that, the return traffic going back must also be allowed. There has to be a rule in the network ACL that allows the port and protocol to go back out again. That's different to security groups, where as long as it's allowed inbound, whatever outbound connections go back are allowed by default. A security group evaluates all rules, whereas a network ACL processes the rules in order until it reaches a permit or a deny. And a security group applies to instances only if they're specifically associated with that group, whereas a network ACL applies to every instance that's within a subnet that network ACL is associated with. So let's go to the console, and what we're going to do is we're going to just head over to EC2, and we're also going to bring out the VPC console. So let's go into EC2, and what we're going to do is we're going to launch a couple of instances. And the first one I'm going to put this into my VPC, so this is the custom VPC we created in this part of the course. And I'm going to put this instance in public 2A. I'm going to select my IAM role, and then I'm going to take the code, and hopefully you followed through this course from the previous section. If not, you'll find this code within the course downloads, and what it essentially does is calls the bash interpreter, updates packages, installs and enables Apache, and then it uses a couple of S3 objects that we uploaded to a bucket, and it essentially just updates an index.html file with a name that it pulls at random from this file. So let's continue. We're going to configure security group, choose web access, which gives us SSH, and we're going to launch. And we're going to do the same thing now in 2B. So we're going to just put this instance into 2B. And actually we don't need to install Apache on this one, so let's just put this one in public 2B. And we don't need to change the roles or add any user data. So we're going to choose web access again, review and launch. So while those are launching, let's head to the VPC management console and have a look at network ACLs. So you can see here the default network ACL, and this top one is the one that's associated with the custom VPC we created, and you can see it's associated with all 6 subnets. And you can see that allow rule that I talked about, and it's rule. So the format that AWS suggests is that you leave big spaces between your numbers so that you can, I suppose, fill them in with other rules later down the line. So they suggest that you start with 100 and then you do 200 and 300, and then the pattern seems to be that you then use the next number for the IPv6 version of that rule. So you have 100, 101, then 200 and 201. And we have the same with outbound. It's identical. You have allows, and then there's explicit denies at the end. So the rules will be processed in order until they reach a deny. And in this case, the traffic will be allowed because it says any protocol, any port, any destination. And we can associate subnets through here. So let's go ahead and create a test NACL. Just going to call it that, and put that in the VPC. And let's have a look at the rules associated with this. So as we can see, you only have the deny rules. There are no allow rules. And the same with outbound. Now what I want to do is go over to the console, and I want to take the IP address of my instance that's in 2B, so not this one, that's in 2A. Let's connect to the instance in 2B. So I'm in the console and I'm going to SSH into this instance. And we're in. And I'm now going to go back and get the private IP address of this other instance, which is the instance that's in 2A. And remember, it's the instance in 2A that actually has Apache installed. So what I should be able to do is, or what I want to be able to do is to ping this instance. But first we need to go back and allow it as in the security groups. So let's just head back over to the VPC management console and let's choose our security group. And we only have SSH in this one at the moment, so I'm going to create one that says all ICMP v4 and another one that allows HTTP, which is, there it is. So, and we're just going to allow any address range. So I'm going to save those rules, head back to the console, and let's try to ping the private. Of course, I've got to go back and copy my IP address again. So let's just go in here, copy the IP address, and then we're going to ping the IP address of the other instance, which remember is in a different subnet, and that's fine. And then we should be able to curl that instance, and you'll see the index.html file displayed, and at the bottom there we can see that the name is, we've got the hi, this is Carly, so that's the name that was given to that instance. So that all works fine. Now let's go back to the VPC management console, and we're going to go to Network ACLs. And so what I want to do is I'm going to associate this Network ACL with 2A subnet. So that's where our web server is sitting. And I click on edit, so now we only have 5 subnets associated with the default ACL, and we have 1 subnet associated with a new custom ACL. So remember, that's what happens when you associate a network ACL, because you can only have 1 network ACL associated per subnet. So we don't have any allow rules, so the expected behavior would be that if we try to rerun those commands, it doesn't work. And sure enough, we're not getting any response. So let's go back over, and what we're going to do is we're going to edit the inbound rules, and we're going to allow, and let's choose all ICMP, and we're going to put that as rule 100 from any source, and then we're going to allow HTTP, and we're going to put this one as following the protocol. Let's put that as 200, and again that's any source. So let's go back, we've created those rules, let's go and try again, and we're not getting any response still. So I've tried the ping, I've tried the curl, and we're not getting any response from our web server. And of course that's because this is a stateless firewall. It's not a stateful firewall like a security group. So we have to go to outbound rules, and we need to add the rules in here. So let's put in rule 100, ICMP v4, and allow, and then rule 100 and HTTP, and that is being allowed as well. Excuse me, I need to change that to 200. Click on save. And now let's go back and see what happens. So we'll run the ping, and that's great. So we've now got traffic going in both directions. And let's try running curl. And that's not working. So the reason being, if we go back to our rules, we have an inbound rule, and that allows ICMP v4, and an outbound rule that allows ICMP v4. Now this is a protocol level, it's not a port level, so it doesn't matter what port the traffic comes back as long as it's an ICMP packet, it's allowed. Now with HTTP, we're sending data one direction to our web server, and it's hitting the web server on port 80, but the return traffic doesn't come back on port 80. It comes back on an ephemeral port. and ephemeral port is a high numbered port. So we're going to put in a custom TCP rule, and we're going to put in 1024 to 65535, and that's the range which most ephemeral ports sit in. And it really depends on your operating system, but we're going to use this, and I think this will work just fine. So what's essentially happening is the traffic hits your web server on port 80, but the return connection that comes back is on a port somewhere within this range. So we just need to allow that return traffic, and we can come back here and hit curl, and now it works just fine. So another thing you can do with network ACLs is you can apply deny rules. And what we need to do for a deny rule is make sure that the rule is reached before an allow rule, because these are processed in order, and the first allow or deny that's reached is processed and nothing happens after that. So what we need to do is we need to make sure that our deny rules, if you want to deny a specific source for instance, are higher in the list of rules than our open allow rules. And I'm going to show you an example of that. So let's just go over and to our instances, and I'm going to take the public IP address of our instance in 2A, which is this one. And I've opened a new terminal window, and what I'm going to do is just ping that instance from my client. So I'm on a Mac working at home, and I can ping this instance via the internet. Now what I want to do is I want to block traffic from my IP address. So the way I can do that is I can come in here and I can add a rule. Let's just put this as 300 that says all ICMP v4. Now I could specify my source IP address here, but if I did it there, the allow rule would still be reached first. So let's just try that. So we put in the IP address that I have on the internet, click on save, and let's go back and ping, and sure enough that traffic is allowed because the rules are being processed in order. So let's just go back, and what I'm going to do is I'm going to copy this up into the 100 rule. And so what I've said is that this IP address and the /32 means this exact IP address. You could put in a range if you like. So we've put in our source address with our /32 to say this exact IP address, and what we want to do now is change this to deny and click on save. And so what I want to do is try and ping that address, and it's a fail. And let's try again to reach that address via curl. So this is trying to reach the web server on port 80, and that's fine, so that works okay, whereas pinging doesn't. And of course that's because we have a deny rule for ICMP, but we have an allow rule for port 80 TCP. So that's it for network ACLs. What we're going to do is we're going to go back into our default network ACL here. I'm just going to reassociate public 2A, and then we now have no associations, and we can delete that network ACL. And the only other thing to do is just to delete instances. So let's just terminate our instances. So going back to the slides, key things to remember: VPC router actually hosts the network ACLs, but they're logically associated with subnets. They process traffic that's coming into ingress or out of egress the subnet, so they don't affect anything that's within the subnet. So if you see questions around blocking access, for instance, between instances within a subnet, then that's a security group. It can't be a network ACL. Again, other exam questions you might get say that you want to deny a specific IP address from sending data. So remember, deny rules are allowed with network ACLs, but there's no such thing with security groups. So you've got to work out the differences between how you might be able to implement that solution. So that's it for this lab, guys.